Hello friends, welcome to Seco. In this video, I am going to explain these three graphs, position time graphs that is given in your textbook. So this first one, let us say that particle, this is x-axis, okay, and particle is here, this is origin, let us say this is origin, and particle is 40 meter away, okay, from the origin. This is 40 meter. So particle is in this position, and let us say there is a clock, and it is the needle of the clock is rotating. So time is passing and particle is not changing its position, it is there, okay. And this situation is represented here, okay. So you can think that this is the actual let us say actual path or actual road. On that road, this car, maybe this is a car, this is sitting there at 40 meter, and even if the clock's needle is rotating, that means time is passing, but that car's position is not changing. This situation can be represented in position time graph like this. This is time, let us say. So here you can see that this is the situation. This situation can be represented in this graph. Here you see that at the beginning, when time was 0, this is time axis. When time was 0, that means when we have started to see the event, or when we have started to record the event. So at that time, the particle or the car was 40 meter away from the origin, okay. This is 40 meter. Now as time is changing, but still it is 40 meter away. This is 40 meter. At any time, after 20 second, after 30 second, still it is 40 meter away, okay. So it is not changing its position. So if a particle does not change its position, then you will see that in position time graph, this plot will be parallel to this time axis, okay. So this is what the graph number 1. Now this is graph number 2. In this case, if you notice it, what happens that, let us say this is the line on which the particle is moving. Let us say this is origin, and particle is moving as time is passing. That means if the needle of a clock is rotating, then the position of the particle is also changing, okay, and particle is moving in the forward direction, forward x direction, along x direction. So, and this graph says that after some time, after a fixed time, maybe after 1 second, let us say after 1 second, if it travels 1 meter, then in next 1 second also it will travel 1 meter, okay, and next 1 second it will again travel 1 meter. That means in every interval of time it is moving same distance, and this situation is represented like this in position time graph. Let us see the position time graph. This is the actual event that is happening, and this is represented here in this position time graph. So let us say this is 1 minute, okay. This is 1 minute, this is 2 minute, this is 3 minute, this is 4 minute, this is 5, this is 6, and so on. And let us say this is 10 meter, and this is 20 meter, and this is, let us say, 30 meter. So 10, 20, 30, 40, and so on. So if you look at this graph, you will see that in 1 meter it travels this much. This is around 5 meter, okay. This is 5 meter. So in 1 minute, first 1 minute it travels 5 meter. 1 minute, in first 1 minute it travels 5 meter. Then in second 1 minute, that means from 1 minute to 2 minute, in this second 1 minute it travels again. You see that it again travels this much. This is again 5 meter. So in second 1 minute also it is traveling 5 meter. And in third 1 minute, let us say this is third 1 minute, again it is traveling another 5 meter. Okay, so next 1 minute again it is again moving 5 meter. Then in next 1 minute it is again moving 5 meter, so it reaches to 20 meter. So if you look at this graph, what you see is this is a kind of uniform motion. Uniform motion means it is not changing its the way it is moving. That means its velocity or speed kind of things are not changing. Okay, so it is traveling same distance in same time. So this is a graph of uniform motion. And this one, so this is explained. Now this one, let us see this one. What happens if you notice this? This is also a car is, this is a graph of a car. Okay, car is moving in a straight line, and when time was 0, it was at the origin. That means it was not moving, it was there in the origin. So as time was passing, it was there, almost there, it was not changing position. So if the car was like, this is origin and this is the road, actual road, and we are drawing this axis, and this axis is coinciding with that road. That means we are drawing that road. You can think like that. So let us say the car was there at origin. Let me draw little bigger. And when time was passing, it was not moving. Almost, it was almost there. Okay. So this was 2 second. It was not moving. It was 4 minutes. Still, it was not moving. So maybe car was starting. This car has been started, but it was not yet started to move. Okay, car's engine started, but car was yet to move, like that. Or it has moved slightly, so little that we are unable to draw. Then after 4 minutes, or maybe if we take this in second unit, after 4 seconds, it started to move. Considerable amount of movement has happened, so we are able to observe it. So it has moved very little amount, and in next 2 seconds, when the time was 6 second, we have seen that it has moved like this much. So this much movement has happened. This much movement has happened. Okay, so and then it has started to move, and now its movement, its displacement is increasing. Now this much movement in next 2 minutes. After 8 to 10, it has moved considerable amount of distance. Okay, from this point onward, you can see that it is like a straight line. Okay, so it has slowly increased its speed or velocity, let us say velocity, and then it has maintained its velocity for a long period of time, from let us say 10 second to like 20 second. It has maintained its constant velocity. Okay, because it is like this is a straight line. Then again it has started to decrease its velocity. Its velocity decreased. That means in next 2 seconds it has not increased that much. In this 2 seconds it has increased quite much, this much. But in this 2 seconds it is not increased that much. That means in this 2 seconds its velocity has slowly started to decrease. Okay, so and then finally it has stopped. Here it has stopped. That means time is changing, but its distance is no more changing. It has remained constant. So after maybe 22 seconds, it has stopped once again. So this is the motion of a car. So, okay, so cars motion in on dimension, position time curve or graph can be represented like this. So these are the three curves that I wanted to explain in this video. Guys, if you like this video, if you think that these videos are valuable, they are creating some value, they will be beneficial for some people. If it is not beneficial to you, maybe some people, those are actually learning physics from very basics, or maybe in class 11, like that, you think that if they watch these videos they will get some benefit, then you can share this video with them. If you like this video, you want to uh, help me grow, so that these videos reach to those people, you can subscribe this channel and you can also hit the like button, so that YouTube algorithm thinks that these videos are valuable and they show these videos to more and more people. So you can hit the like button also. Thank you for watching. I'll see you soon in the next video.